Hi, this video is about the idea of impulse in physics. Let's start off with a question. If you're going to go bungee jumping, which of these bungee cords would you prefer to use? Would you like to have a nice elastic stretchy cord, or would you be okay with a metal chain? Isn't it true that both of these could stop you from hitting the ground, right? What's the difference then? If both of them could stop you from hitting the ground, then shouldn't both of them be good, viable options for bungee jumping? Well, of course, you know the answer is no, but how do we know this? The answer comes from impulse. So, if you recall from a previous video, I showed you how Isaac Newton went from his famous F equals ma equation and worked out a new expression that involved this quantity called momentum. Momentum is mass times velocity. And he found that the change in an object's momentum is equal to this quantity of force and time multiplied together. So this quantity right here, force times time, we call the impulse of an object. This Ft is called impulse. And there's a math equation, or there's a math symbol for impulse. It's capital J, but I'm not going to use it in this video. I think it just makes things a little bit too complicated for what we're dealing with. It's a pretty simple idea that if you take the force and the time and multiply them together, then you have the impulse that an object experiences. And this impulse is equal to the change in an object's momentum. So let's look at an example of this. Let's say you have two identical cars going at the same speed, and so they have identical momenta. One car crashes into a haystack, while as the other car crashes into a solid brick wall. They both have the same starting momentum, and they both come to rest. And so, because of that, they both end up having the same change in momentum. They both go from a momentum of, let's say, 1,000 to 0. So they both come to rest. They both have the same change in momentum. And so, therefore, they both have the same impulse as well. Okay, so what's so special about that? What does that really tell us? Well, if you look at what impulse means, impulse is the product of force and time. If you consider the force on the car and the time that the force is applied for, it gives us an answer to this question: which car is safer to be in during the crash? If you consider they have the same amount of force times time, they both have the same amount of impulse because they both stop. What's different about the amount of time that they stop in? If you crash into a haystack, if you watch the screen here, the amount of time that it takes for you to slow down is dragged out a little bit. It's a kind of a gradual stop. And because of that, it exerts a smaller amount of force on you. Greater time, but the same amount of change in impulse, or change in momentum, same impulse, means less force. On the other hand, if you crash into a brick wall, the time that it takes for you to stop is very, very small, microseconds. You stop almost instantly. And because of that, if it's a very small time, it's still the same amount of impulse, which means the force must be huge. So the difference between the two situations is the amount of force acting on the car and the amount of time that the force is applied for. If you multiplied the force and the time together, you would still get the same number. It's the same amount of impulse, but what matters is the force is a lot lower for the haystack than it is for the solid wall. And so if you're in the car, it's better to have less force acting on you. And so you're safer to crash into a haystack rather than a brick wall. Whenever a momentum changes, there's always a trade-off between the amount of force acting on the system and the amount of time that the force acts for. And so this is a pretty big principle in the idea of momentum and impulse. Whenever you're trying to slow yourself down or change your momentum in any way, if you can find a way to extend the amount of time that you're slowing down for, that minimizes the amount of force that you experience. On the other hand, if you have a really short amount of time to stop or change, then that means you must have a really big amount of force acting on you. And so this allows us to answer that question that we started with. Um, The impulse, let's add to this equation. Let me get myself out of the way first, because I know I'm going to need this space. Let's add to this equation. We're going to make it like a four-part equation here. It's going to look a little crazy, but if you think about what an equal sign means, it just means they all mean the same thing. So we've already said that the quantity force times time is known as the impulse. And the change in momentum is simply the mass times final velocity minus the mass times initial velocity. So we think about momentum as mass times velocity, but if the momentum is changing, that means the velocity is changing likely. And so this idea here, this equation at the top of the screen, is called the momentum impulse theorem. And it shows that there's always a trade-off between the amount of force that's acting on an object and the time that it takes to change that object's momentum. So now we can finally come back to our original question. Which of these is better if you're going to be bungee jumping? Both of them can stop you. That's true. Both of them can arrest your momentum completely. However, one of them does it over a more gradual, longer extended period of time. And so therefore, if it's a long period of time that you slow down, then the force acting on you during that time is small. The metal chains can stop you, but they stop you pretty quickly, almost instantly. So a small amount of time means a big force acting on you. And so you don't want to experience big forces. So that kind of explains to you the difference between the two, even though both of them can stop you. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.